I'm Rachel Fuller, and today we're going to get a brief introduction to graph theory. Why should I care about graph theory, you might ask? Well, graph theory is behind everything from Google Maps to the way social scientists model the spread of rumors. To get a better idea about it, we're going to need to go back to the 18th century city of Königsberg, Prussia. Now, the people of Königsberg had an interesting hobby. They would start at their own home and try to make it across all 7 of the city's bridges to make it all the way back to their own house. So that's 7 bridges exactly once in a full loop. The problem was they could never quite manage it. To get a better idea about why, we're going to try and draw a few walks ourselves. Okay, nope, that failed. Let's try starting somewhere else. Okay, also not working. Let's try starting in the triangle for a change. And this also fails. So now the question is, am I just really incompetent at choosing paths, or is there actually something about this that makes them possible? To answer this question, we're going to need some graph theory. So what we have here is our graph representation of this map. Everything that's distracting or extraneous, like the shape of the river or the placement of the bridges, is gone. All we have is the connections. So this right here, this landmass, corresponds to this vertex. This edge corresponds to this bridge. And say we go from here to here, well, that's just like taking a walk from here to here. And it's in fact called a walk. So one thing we'll notice is that each vertex has either 3 or 5 edges, which means that each one has an odd degree. So this is going to be pretty helpful. We know that we're going to need to start on some landmass, and the first thing we're going to need to do is take a walk out. But we still have 2 edges left to go. So we're going to need to walk back in on one of those 2 edges. Here we are. But we still have this edge left that we need to take. So we're forced to walk out off of our landmass and somewhere into the rest of the map, which is not what we want because we haven't made a full loop. But wait, you might say, we still have our vertex with a degree 5. So we're out in the rest of the map in this case, and we're looking at our degree 5 vertex. So we can walk back in on this bridge, but unfortunately we're forced to walk back out. So the answer to this problem is that it is in fact impossible, which is just what the famous mathematician Leonhard Euler proved when he solved this problem in the 1700s. This seemingly discouraging answer founded the whole new field of graph theory that we know and love today.